What does it mean, Milks? What does it mean?
Acid-base strength?
Yeah.
Oh,
What does pH really mean?
I will tell you. It means the negative log of the H plus concentration.
Yes, it
Did
does.
you want to hear that?
I did. I love that common equation. But we're not actually going to teach you that equation. We're going to teach you a
Yeah.
simplified version
Ooh.
of it,
Yes.
which pains me to teach you the simplified version. But
Yeah.
we must move on.
Logs are not my favorite, but man, it does actually work.
I like logs. They
I-
burn in the fireplace.
I like those kind of logs. I mean, it's the logarithm.
Logarithms. Oh, so you some math can show up.
Ooh,
in it.
cute.
If
Don't
we
want
wanted
that.
to teach you this video in a different way,
We
it would just be math the whole time.
Yes.
But we're going to teach you in a way that makes it a little bit
Visca's not here, so we're going to do it this way.
Mhm.
pH values between 1 and 6 are considered acidic
Mhm.
because they have a relatively higher concentration of H plus than they do OH minus.
Right. That's
Okay?
what makes them acidic
There's,
solutions.
yeah, there's more H pluses
Period.
than OH minuses
7's neutral.
because there's the same amount.
So any salt put into water would have a pH of 7 because it doesn't produce those ions that we're talking
And
about.
then water has a pH of 7 because if it does happen to move a hydrogen
Right.
ion over, it creates one hydrogen ion and one OH minus, and they cancel each other out.
Right. It's the equilibrium expression
There you
for
go.
water. But
So then between 8 and 14 is
Base.
basic because now there's a relatively high concentration of the OH minus. They are winning and not the H pluses.
because if an H plus shows up, the OH minus is going to react with it to make
Yeah.
water, which is neutral, and thereby eliminating the H plus concentrations.
So this used to be in our reference tables. I'm going to take a second to draw it. Hope we don't run out of time, but this was a really cool one. So then H plus is down here.
And it gets smaller and smaller as it goes. So this was a different visual for remembering
Yeah.
the concentration. So visually, like
can
the
see-
larger ones,
You can
means
see
higher
here the concentration is really high
and there.
of H pluses, and over here the concentration of OH minus is really high.
So it's kind of an inverse scale, right?
And in the
When,
middle, they're about the same.
right. So when H plus dominates, it's an acid. When OH negative dominates, it's a base. If it's a balance, an equilibrium, it's neutral, pH 7.
Sweet.
There
That
it is.
actually was actually in the reference tables for years.
Strong acids will dissociate completely. So hydrochloric acid, hydrofluoric acid, the type of acid that you would see in
There's 5 of
TV
them.
and drama.
sulfuric acid, hydrochloric acid.
Right. These are the strong ones that would see in TV and drama as melting stuff, causing physical damage to
Yes.
people, reacting with metal. Okay.
Sure.
Those are extremely strong acids. They
But
dissociate.
scientifically, the strong means they dissociate completely. That's the key. It doesn't just mean
concentration.
because
Well,
I
it
can
does.
make hydrochloric acid that is at a very slow concentration and will barely make you itch
But it's technically a strong acid.
because it dissociates completely in water.
Right.
That's the key. They generally have a pH range of 0 to 4.
Right.
But the real definition is dissociate completely.
Weak
And
acids.
conversely, they do not dissociate completely. We're not going to get into the equilibrium. We could get into some other complex math.
APChem.
Yep.
Not going there.
They generally have a range of 4 to 6.9, but they're weak because they don't dissociate completely, not because they won't hurt you.
Right.
They could still hurt you, but in high concentrations. Okay.
Same reason when strong bases will dissociate completely. These things have a pH of 11 to 14, like concentrated drain cleaner tablets, concentrated laundry detergent
Lye.
tablets, packets, cement and concrete even, because of the ingredients have extremely strong pHs, so you want to wear gloves and protect you when you handle that
Yep.
stuff.
Yep.
Weak bases.
Weak just means incomplete dissociation, a little bit lower down in the range, and we're moving on.
Let's get into what it means.
Okay.
So each step on the pH scale relates to that hydronium concentration
This is key.
in molarity.
Correct.
Okay. So a pH of 1 technically means you take the number 1.0 for 1 molar and multiply it by 10 to the negative 1,
Right.
which turns into a concentration. So I'm going to circle a couple things. So a pH of 1, that 1 doesn't mean that one.
No, it's
Doesn't mean that one. It
it's
means
this negative
this
one up top.
negative 1 up there. So when you take 10 to the negative 1,
You move the decimal place one time, and you get that
To the
0.1
left.
molar.
you get smaller and smaller the bigger the number of pH gets.
Right.
So pH of 2
Now the 2 comes up, and now
means,
it's 10 to the minus 2.
which is smaller than.
But now you need to move the decimal over, and now pH 2 has a less concentration than pH 1.
Right.
Notice
Of
we're starting at the most acidic at pH 1. Right.
Let's see
Actually,
another
pH
one.
0 is even crazier.
Let's
Right.
see another
But so if I take it up to 7, now I got a pH of 7. The 7 goes up there, and then all of a sudden we have a concentration even lower. Okay.
So what if I had a pH of 14?
So I'd put the 14 up and I'd move it over 14 spots. This is really how logs work in shorthand.
Mm-hmm.
I'm not typing it into no calculator.
Right.
So there'd be 14 zeros in front of that one, even less concentrated in H plus.
So that's why a pH
Specifically.
of 14 means very low H plus concentration, which, as we know, means very high OH negative concentration.
Right. We are not going to get into POH. That's AP Chem. Notice this 10 times increase. It's big because that's what happens. So let's talk this through. If I'm going from pH of 4 to a pH of 5, I'm becoming more basic. So I'm increasing my basicity. So my OH concentration is increasing by a factor of 10 because in between 4 and 5 is 1. So then times 10 is 10. So one step is a times 10. 2 steps is not 20. It's 10 times 10, which is 100. Okay, there's another key. So we're going to make sure we do that in this next piece. Okay, so the second piece, becoming less acidic. Okay, it's becoming less acidic going from 4 to 5. It's becoming more neutral. So my H plus concentration goes down. And because I only moved a pH of 1, it's going down by a factor of 10 times. Okay, this next example is going to work out the same way, but that 10 times is going to change significantly.
Yeah, so for every step, you do 10 times 10 times 10 times
Correct.
10. So if it's 5 steps, you do 10 times 10 times
Correct.
10 times 10
Yeah,
times
it's
10.
exponent. It's not 10 times
It's not 10
5.
times 5. No, that's 50. 10 times 10 is 100. Times another 10 is 1,000.
Right.
Times another, etc.
The key is that we need to know that because you know the reagents is going to put that 10 times 5
Oh, yeah.
is 50 on there as a choice if you don't know your stuff. So now 13 to 10, I'm moving 3 spots and I'm becoming more acidic because I'm moving closer to the acid range by 3 steps. So my H plus concentration increases, but 10 times 10 is 100, times 10 is 1,000. So it's 1,000 times more concentrated in terms of H plus. Conversely, if I'm going from 13 to 10, I'm actually becoming less basic. I'm becoming more neutral. So my OH minus concentration is going down. Again, I moved a step of 3. 3 steps is 10 times 10 times 10, which is 1,000. My OH concentration went down by 1,000. 3 steps, 10 to the third, which is 10 times 10 times 10, which is 1,000. Good?
Yep.
Good. Let's do a little bit more. This is right off the practice packet. So we're going to do a few right off the practice packet. We'll
Yeah.
talk about stronger or weaker even on this too, okay?
Do it.
So 5 to 3, my pH, my acidity is becoming stronger.
Yeah.
So stronger acid. I'm becoming a stronger acid. I'm going 2 steps. 5 to 3 is 2 steps, so that's 10 times 10, which is 100. I'm 100 times more concentrated. H plus concentration. Okay, good. 8 to 4. 8 to 4, I'm moving 4 steps. So 4 steps is now 10 raised to the 4, which is 10 times 10 times 10, which is 1,000, times another 10, which is 10,000 times more acidic. So there's 10,000 times more H plus ions in solution. That's a lot. Okay, that's a lot.
That's why we needed the logarithmic scale to represent it in a simple number instead of all this scientific notation.
Yeah, because
and
it's
huge
number
numbers.
1 through 14 is a lot easier to understand. Let's do 4. Let's just jump one, see if everybody's paying attention. If I move from 14 to 7, I am moving 7 steps. Oh my goodness, that's 10 to the 7, so that's 10 times 10. How about 7? How about 10 7 zeros after it? Make it with 7 zeros, man. 4's got 4 zeros, 2's got 2 zeros, 7's got 7 zeros. We're gonna play a numbers game. There you go. 10 million times. 10 million times more acidic H plus ion concentration
Mhm.
going up, and we out.
Yeah, I don't think we have any more.
I think you can do the
examples.
rest of the practice all by yourself. Follow
Remember.
the steps.
However many steps it was, is you raise 10 to that number.
Yes.
And it's more acidic or more basic depending on which direction it's going
there you go.
on the pH
Fair
scale.
See you guys.